Alright, so this one right here, graphing the radical function. And plot at least 3 ordered pairs. I'm going to make you plot 3. Just like with parabolas, I made you plot 5. This time it's 3 because we're really essentially making half of a parabola, right? So, first thing I want you guys to notice here with this problem is, could you quickly identify what transformation took place? Because that minus 2 is inside the square root, we should know what happens there. It's a horizontal translation, 2 to the right, but even if you didn't know what was going on, do you have any excuse whatsoever why you can't start here first? Type that thing in, get a picture of that graph and say, oh look, it just moved 2 to the right. And then Mr. Cook wants 3 points. So then why don't I just go ahead and go to my table of values and plot 3 logical points that aren't ridiculous decimals. Like for example, I have a spot right here at 2, 0. So 2 to the right, and then 0. And then we have 3, 1. And then skip it, 6, 2. There you go. You've plotted your 3 points. There's your curve. Food for thought. Why does it say error right there? What would happen if you put a 1 right there? 1 minus 2, you'd have to square the negative 1. Hey, imaginary number. So that's why you see errors there. Sometimes you use square root functions. Okay? So same deal right over there with this one, with B. Okay? No reason why you can't use a graphing calculator. Remember that when you type that square root in there, make sure you close off that square root with a parenthesis and then hit the plus 3. Okay? These problems here, a little bit more elaborate, but couldn't you still? And I am not going to do that cool graphing calculator trick here. I'm actually going to do it without a graphing calculator. But could you use a graphing calculator and just plot 3 logical points? Absolutely you could, and you should, if you're lost at anything that I'm doing right now at this point. Okay? So, first move. Understand what's going on here. Number 1, can we figure out where the quote-unquote vertex is at, or in other words, the starting point? We're still doing the opposite and same game with those 2 numbers right there, right? So the opposite of positive 3 would be a negative 3. The same as negative 2 would be negative 2. So our starting point should be at negative 3 and then negative 2. What else do we have going on here? Well, what else we have going on is that because of that 2 that's sitting there in front of the radical, we have a vertical stretch of 2. So, just like any square root function, isn't the square root of 0 a 0, so we don't move, we plot a dot. The square root of 1 would be 1, so instead of going up 1, we're going to go up 1 times 2. It's very similar to that work we did with parabolas if you think back to chapter 4, isn't it? Hit the reset button, go back here. Now, wasn't the square root of 2 a decimal? So we skip it, so I'm not going to go 2 squares. The square root of 3 was a decimal, skip it. The square root of 4 was 2, but instead of going up 2, I'm going to go up 2 times 2. So from here, if I go 4 to the right, I'm going to go up 4 squares. 1, 2, 3, 4. There we go. I've plotted 3 points. There's that graph. Okay, we look at this guy right here. Same thing. We have a vertex, quote unquote, opposite same game at 3, 3. So there's a 3 and a 3 right about there. Because it's a 1/2, we have a vertical compression of 1/2. So instead of going over 1 to the right and up 1, I'm just going to go up a half. And then 1, 2, 3, 4, instead of going up 2, like a parent function would, because the square root of 4 would be 2, I'm going to go up half of 2, which would be 1. And there would be that curve, just like that. Okay? Let's finish up with these problems, these last problems here. Alright, okay, so question number 20. You've seen this song and dance in many different forms and versions. This one's no different. Now we're just doing it with radical functions, more specifically square root functions. So if we take the parent function square root of x and do a vertical stretch by a factor of 2, we should know where to put that. That always goes as a multiplier. They even give you the keyword there, factor, so we know to put our 2 right there. Horizontal shift of 3 to the left. If you want to move something horizontally, it needs to be within the parent function. In other words, you need to change x before you take the square root. And the only way you do that is extend that square root bar. And if I want to move it horizontally 3 to the left, that means I need to have a plus 3 under there. And then after the square root is finished, after I've taken x and added 3, and after I've square rooted, and then after I've multiplied by 2, now I have a y value, and that's the only way I can take that y value and move it 2 units up. So then we can do that and write that as +2. So our final result should be this right here. Looks exactly the same, but now it's in red. Ooh. So look at number 21. You're doing the exact same thing. Just be careful when you move left and right. Remember, it's an opposite game. And then when you move up and down, it's the same game.